Good morning, good morning, good morning. Hope all is well and everything is okay. All right. Let's see. Good morning. All right. So last class, I believe. Okay, just checking something. Last class, I believe we did 6-1, and it was 6-1. Let me check. Yep. So we're gonna do 6-2 today, and I think that's where we'll stop. Let me check. I'm running a little bit behind. Not even gonna lie, in all transparency, I was running a few minutes behind because I woke up at 9. It's one of those days. I did not respond to my alarm at all. Where it go? All right, so yes. So our next test, 5-1 through 5-4, 6-1, 6-2. So I'll pause after 6-2, which is, this one section today. And then we'll put a test up. Next class, I'll open up the floor for any questions that you guys may have, generated over the weekend. But, every day is opportunity for questions. Yeah, and I'll post that test. Okay. I didn't even put up homework from last class. Nope, my fault. I thought I did that. Yeah, I'll post that too. Sorry about that. All right, so let's go ahead and get into 6-2. I keep doing it. Trying to draw Steve better than what I'm doing.
Seems like it didn't want to work.
Well, I kept coming down too slow. I was trying to. It's actually not the pen fault. I just was drawing it. I just wasn't drawing it the best way possible. I was trying to do all right. I'm not really a drawer. So, and look, and sometimes it's so funny. Sometimes I get up here and I get to writing, and I'm just like, you know what? People are watching me right now. At some point, I should just give this up. But it's all good. The normal model. The normal model is the most widely used probability model for continuous numerical variables. The curve used to visualize this is called the normal curve or normal distribution. I believe we talked about that in the earlier sections of this class. Our difference between our normal distribution versus the, being skewed left, skewed right. I think we did that in this class. If not, this is the shape of our normal distribution right here. Yeah, the bulk of our information in the middle, and it evenly goes out or thins out as you go away from our mean. Our mean is in the middle, which is your average. So your average is in the middle. That's where the bulk of your data is. And then as you move away from the average, whether it's to the right or to the left, that means to the right is greater than, to the left is less than. As you move away from the average, there's less and less data. All right. It's called the mean. Okay, that's good enough. All right, so we have some notation here. We have these Greek letters, and the first one is mu. It kind of looked like a U with a long stem on the left, so could have drew that a little better. Like I said, it kind of looked like a U with a long stem on the left. It's called mu, and it's the mean of a probability distribution. Then we have sigma. And that's you can just call it sigma, but I just want to emphasize that this is lowercase sigma. Capital sigma is like that, which means something totally different. That's the addition of our terms, the summation. So that's lowercase sigma. This is capital, sigma right here. So like I said, once again, you can call it just sigma. I just want to emphasize that we have seen regular size or capital sigma. And so if you saw the word sigma twice, that's why this is lowercase and this is capital. But anyway, lowercase sigma will be the standard deviation of our probability distribution. So we see those symbols. All right, so little facts about normal distribution. It's symmetric about the mean. That means your mean is in the middle, and then everything reflects on each side of the mean. So whatever's going on the right side goes on the left side of the mean, vice versa. It's unimodal and bell shape. Like this. Mm. All right. So and then the notation capital N. Then you have parentheses mu comma sigma tells us the mean or standard deviation. So basically, we have this right here, capital N, parentheses 75, comma 3. That means that the mean is 75, and the 3 is your standard deviation. All right, so the standard normal model is going to have a mean of 0 and standard deviation of 1. That means your mean will be in the middle, and which is going to be 0. Let's see where you deviate from that in 1. Did I skip something in this book? So we didn't introduce z-scores in this section. Okay. So good. Takes us into z-scores. We talked about this back in chapter 3, introduced in chapter 3. Let's see what's this. All right, so we're gonna use these z-scores to convert data values to a standard way. What's the way we're gonna use to convert? Yeah, data values to a standard way of looking at your data. Um, and it's going to convert your data values into how many standard deviations it is from the mean, or they are from the mean. Convert this data values. I should say the day right here. They are. All right, so the formula is going to be your data value minus the mean divided by your standard deviation. Or since we have our symbols now, x minus mu divided by sigma. You guys should have a z-score chart with that. Yeah, page 2. And we're all going around z-scores to 2 decimal places. All right, so we're always going to round our z-score to 2 decimal places. And then after we found our z-score, we're going to go to the z-score chart to get our probability. And that chart is supposed to be on pages A2 and A3 in the back of your book. I'm trying to confirm that right now. Yep. Okay, yep, we're good to go on that. All right, let's see. Very good. Yep. Good example. I'm using both of those. All right, so we have small newborn seal pups have a lower chance of survival. Suppose the length of a newborn seal follows normal distribution with mean length of 29.5 inches and standard deviation of 1.2 inches. What is the probability that a newborn selected at random is shorter than 28.0 inches? 28.0. All right, so first thing you want to do is convert to a Z-score, and it is always going to be whatever your data value is, whatever data value you have that's in question. So we're talking about the probability that a randomly selected newborn seal is shorter than 28.0. So that's our data value, that's our X. So whenever dealing with word problems, I like to write down our given information first before we start doing a bunch of stuff. So our mean, all right, our mean is 29.5. Sigma standard deviation is 1.2, and our data value in question is 28.0. Right. All that was given from the problem. So now we use the formula. Do 28 minus 29.5 over 1.2. So we have negative 1.25. Any problem with that? All right, next step. Go to the chart. Now I'm going to show you what the chart looks like, but I'm going to explain the chart first before we go to the actual chart. So we have our Z-score. It's negative 1.25. The way the chart is set up, it's like this. Starts with negative 3.4, goes down to negative 3.3. We go all the way 3.3 to 3.4. Then up top is 0.00. Somebody's unmuting. Does somebody have a question? All right. So this is how it's set up. You know, you have negative, like I said, on the left column, negative 3.4, all the way to positive 3.4. Then on the top row, 0.00, 0.01, all the way to 0.09. So everything to the farthest digit, we have a right digit, farthest right digit, and then we have everything before that. So that is what we're going to look for over here. So this 1.2, negative 1.2, I'm going to look for over here. And then I'm going to look for the 0.05 up here. And so where they meet is what my answer would be. Okay, everybody clear on that? So the 1.2 will be on the left column, and then my rightmost digit, which is the 5, will be on the top row, and that will always be the case. So let's say if I have 2.73, 2.7 will be on the left column, and then 0.03 will be up here on this right row, this top row. Okay, that'll be always how you break it up. All right, questions on the breakup before we actually go to the chart. All right, that will always be how you do that. So let me see, I got this chart somewhere. All right, so this is the Z-score chart. Make sure you all see the same thing. Yep. So we look for negative, yep, negative 1.2. Well, I can't write on it like that. All right. Okay. All right. All right, so negative 1.2 is right here. 0.05 is up here. And there is our value, 0.1056. All right, we'll talk about what it means in a second. I just want to make sure you're okay with finding the value all right there. There we go. All right, so I switched off the another screen. I'll have to get back on. So also I want you to take note that up here, whatever value you have represents what's to the left of. Notice how it has to the left of. So all of these are negatives. When you go to A3, all of these are your positives. Remember I told you go all the way down to 3.4. It starts with negative 3.4. So it goes from negative and it goes all the way to positive. So once again, if you have a negative in front of your number, you will use A2. If your number is positive, you use A3, but you still use it the same way. It just gives you an idea as to what's going on. But the value that they give you represents what's to the left of your Z-score. So there's going to be a key word or key phrase that will let you know whether you're dealing with what's to the left of, looking at what's to the left of, or what's looking to the right of. We'll talk about what you would do if you were to have a scenario that asked about what's to the right of in a second. But left of means less than, shorter than, below, colder. And I'll give you some key phrases before we leave that will just signify we're talking about to the left of the Z-score. Remember, whenever you're looking at your generic number line, if I look at number 1, everything to the left of number 1 will always be less than it. Everything to the right of 1 will always be greater than it. Same thing if you would look at 3. Everything to the left of 3 is less than it. Everything to the right of 3 is greater than it. So if we're talking about to the left of our Z-score, we're talking about everything that's less than it. So any phrase that signifies less than will let us know we're dealing with the left of our Z-score. And then, like I said, when you talk about greater than or to the right of, and stuff like taller or above, hotter, stuff like that will signify greater than and to the right of. And so, like I said, we have to do something a little, have one more step when we're talking about to the right of, but the chart value always gives you left of or less than. So let's get to the notes and write that down. Now, also, let me say this. This book gives you a chart to use. It is to your benefit to use the chart that the book gives you. So if you go Googling, and you guys have access to this through Math Lab, you have access to the book. But if you Google Z-score charts, there are a couple of different Z-score charts that you can read, that you have to know how to read them. And they're not read the same way that this chart is. This is one of the easier ones. So I would suggest you just go ahead and lean on the Z-score chart that the book gives you. But sometimes, a lot of times we Google stuff and just try to use our own thing. So just give you a heads up. It is possible that you can pull up a Z-score chart that does not read the same way that this one reads. So, but it gives you the same result if you know how to use it, but you have to know how to use it. Yeah. All right, so this is what I was mentioning before I went back to the notes. Chart value is always less than. Chart always gives to the left of, which is the same thing as less than, just rewording it, just make sure we're clear. Um, less than.
Mr. Tucker,
Mhm.
I have a question. For the Z chart in our book, you said it was like on page A2?
A-2, A-3.
Okay, A dash, because I just tried to look up A2 and it wouldn't populate, it wouldn't come up.
Yeah, I think I wrote A dash. Oh, you know what? I put the dash right there, but it should be A dash. Sorry about that. Thank
Let me
you.
see, A dash 2.
That should do it.
Oh, okay, there it is. Thank you.
That was my fault. Thank you. So it's A-2, guys, A-3. All right. Appreciate that. Thank you. Thank you. That is important, as you saw. All right. So there will always be a key phrase. I said key phrase. There will always be a key phrase that will let us know what to do. So in this problem, our key phrase is shorter than. So our key phrase in this one is shorter than, which is less than. So that means we can just use the z-score chart value. Mm. All right, so basically our conclusion is that the probability that a newborn seal will be shorter than 28 inches is 10.56%. Or they could have said something like, or about 11%. So it just depends on what option they give you in your in my math lab to choose from. But just don't be thrown off if they decide to round it up to a whole number. So just throwing that possibility out there. All right. There you go. That's all the token. Yep, not a problem. Yep. Where's the problem there? Meet myself with that. I'm going to be 30, because that's similar. What up, would be 30? Let's go 27. So we didn't put me in that spot. Matter of fact, let's do 32. I don't know what possible this time. Yeah, 32 is fine. All right, so what is the probability that a newborn selected at random is longer than 32 inches? So before we did shorter than, this time we're looking at longer than, and how that would change the process, or at least add a step to it. First thing you want to do, just like before, is to find our z-score. This time x is 32. Our mean, we're still in the same problem, so the mean and standard deviation is the same. All right, our z-score is going to be 2.08. Any problems with that? Any problems? All right, so now I get the chart. And let's still copy the words. All right. So we look for 2.0 on the left column, 0.8 top row, and look for it to meet up in the chart. And 2.0. And 8.9812. So I'm looking at 0.9812. All right, so most definitely make sure you try this chart stuff out, even if you don't do it right now. You do it at some point on your own. Make sure you're okay with reading this stuff. All right, any problems? All right, so now we need to come to our conclusion. Our key phrase here is longer than. Let me change it. All right, so longer than is the same thing as greater than, which is also the same thing as to the right of it. But the chart value All right, so chart value always represent what is to the left of the z-score. To find out what is to the right of, you subtract the chart value from one. And something we didn't mention in this section, I don't see it in here, but it's going to talk about at some point. Everything under the curve is equal to 1, so that's why we need to subtract it from 1. So when you talk about symmetric about the mean, what you mean in the middle, that means 50% of your data is to the right of your mean, 50% of your data is to the left of your mean. And all of that adds up to 100% or just 1. So everything under the curve is equal to 1. All right. So we'll find our probability. Let me just do this. Longer than all right, so the conclusion here is the probability that a newborn seal will be longer than 32 inches is 1.88%, or about 2%. Any questions? We'll look at one more scenario. Let's see if that will be percentile or not. Yeah, let me check out one. Okay. All right, so last one like this. What is the probability that this randomly selected seal will be between 27 inches and 31 inches long? So this time we have two data values that we have to give an account for. I'll call the first one X1. Matter of fact, we just go ahead and write the mean first, which is 29.5. And deviation 1.2. X1 is 27. X2 is 31. So we have to find two z-scores. All right, so those are our two z-scores. Any problem with that before we go any further? All right, so that's the first step. Second step, with those chart values for each one individually. All right, so go to the chart. Read it just like we did first two, and you get 0.0188 for the first one, 0.8944 for the second. So just to give you a visual on what we are about to do, why we're doing it. If I can get this thing right. All right, so talked about before that the chart value that we give will always represent what's to the left of the z-score. All right, so that first percentage 0.0188, I can write that right here. That's represented right there. And then here, 0.8944. So if I want to know what's in between those two, I would just subtract this part from this part. And so that's what we're going to do. So if I want to find between So if you want to find between, you're going to subtract the chart values. Notice we are subtracting the chart values. We are not subtracting z-scores. subtracting chart values. These do not subtract z-scores. Same thing with what we subtracted from 1. We subtracted z-score, I mean not z-score, the chart value from 1. All right. So between, we're going to do 0.8944 minus 0.0188, which will be 0.8756.
Mr. Tucker, I'm sorry, I have a question.
Mhm.
You said don't subtract the z-scores, but isn't that just what you did in the green? You subtracted the z-scores?
Those are your chart values. The
Okay.
z-scores were these. Yeah. So
Okay.
when you get these values, though, because the only reason I mentioned that is people have done it in the past, they will subtract these values right here. And I'm saying the z-scores take you to the chart, then you get a chart value. The chart value is what we actually subtracting.
Okay, thank you.
Mhm. All right, so this means that the probability that a newborn seal will be between 27 inches and 31 inches. Oh, I meant to write that as a percentage. I think this book needs one. So it should be 87.56%. All right, any questions? Any questions? All right, so we only have three scenarios. It's less than, greater than, between. And so with those three scenarios, each one of them have a different action. If it's less than, you're going to use the chart value that they give you. If it's greater than, then you're going to do 1 minus the chart value. Then if it's between, you're going to subtract the 2 chart values. And then as mentioned before, there can be keywords that will dictate whether it's less than or greater than. So less than we just saw shorter. Okay, there we go. And longer. Say taller. Let's see, below, colder. So hopefully there's enough examples. Pretty sure there are more out there. We're just giving an idea as to you know what what are some keywords that will dictate less than, and then there are some keywords that will dictate greater than. And as far as between, between, we see any other words that they would use for between. Yeah. Any questions on any of that? Mhm. So as always, try this stuff out. If you have any questions on it, I am here to answer those. There's one last thing in this section, which are your percentiles. All right, so we're looking at percentiles. The kth percentile of a set of data is a value such that k% of the observations are less than or equal to the value. Let's see, D plus U. Okay. So just give you an example of that, how it would be. All right, so just an example of how percentiles work. Jennifer just received the results of her SAT exam. Her SAT math score of 600 is in the 74th percentile. What does this mean? That means 74% of the people who took the exam scored 600 or less. 26% scored better. And so we got a 26 from 100 minus the 74. That's 100% in all. Don't think I'm going to do any more with percentiles other than making sure you know that relationship. Yep. If I see anything else, I'll let you guys know. But yep, that's it. Questions, questions, questions. So, I have to post some stuff for you. Like I said, I forgot to post um, last class homework assignments, so I'll post those and today's, and also look to post a review for you. So next class, we will open up the floor for questions first. See if anybody have them. See if anything's generated over the weekend, and then we will talk about how we will move from there. All right. Any questions or concerns before we close out? That's good. That's straight. All right. So you guys have a great weekend. Have a great 4th of July. Don't forget, well, Monday was supposed to be off. So hopefully your teachers, if you had a Monday class, teachers gave you that Monday off. Other than that, have a great 4th. See somebody saying something in the chat. Oh, hold on. Oh, thanks. Appreciate it. Appreciate it. So you guys have a great 4th. Be safe. And I will see you on Tuesday.
Have a good weekend.
Thanks. You the same.